Okay, so today is October 6th, and we're going to start a new chapter today, Chapter 6. What you're looking at on the screen is a flyer about a business and technology virtual career fair. It's going to happen next week on Wednesday, October 14th, between 12 and 2. It's open to all majors, not just business majors, and they highly recommend that you wear professional attire and have your resume ready. You can attend only if you register through qccuny.edu/hireqc. And employers will be recruiting for positions, so come prepared. So this is the time you should start thinking about it, because October is the time they actually hire for internships in the summer. So I don't know if it's virtual or in person, but you should definitely check it out. Okay, and if you have any direct questions about the career fair, you can contact the Career Center directly. So I'm going to share Chapter 6 slides. So today we're going to talk about random variables and probability models. But before we do that, I want to show you a quick video. And we're not going to watch the whole video, it's just 5 minutes of it. And hopefully this is going to work. So let's see. Okay, so I have to share this, and hopefully you can hear it. Okay, so I'm going to pause a moment just to make sure, was everyone able to hear that? Great, okay. So let's go back and start that again.
Professor, we can't hear anything.
Okay, I had to switch back and forth, so I don't know why you were not able to hear. Oh no. Okay, so did anyone hear anything in the beginning? Oh gosh.
I heard somewhat in the beginning, but then afterwards it faded and then I couldn't hear anything.
Okay, so I don't know why it does that. Let's see. Okay, let me try it one more time with something else. Okay, so I'm going to put subtitles with it because it's important for me to. So let's do this again, and I'm going to start with subtitles. Okay, so trying it one more time. Their eventual conclusion: the accident was most likely caused by O-ring failure. O-rings seal the field joints holding together the rocket boosters that would lift Challenger into orbit. The O-rings were supposed to contain hot, pressurized gases within the boosters. That morning, due to O-ring malfunction, one of the field joints failed. A broader finding of the commission was that NASA hadn't adequately evaluated the risks of this failure or any other. So could the disaster have been predicted? The first step in a probability analysis of the field joints is to calculate the probability of failure in one of them.
Under the Challenger flight conditions, the probability of failure of a particular field joint came up with 0.023. That means the probability of success of an individual field joint would then be 0.977. Okay. Now, that's the probability of success of one field joint, but there are 6 field joints. So for the whole system to succeed, all 6 had to succeed.
If even a single field joint out of the 6 failed, that would have caused a shuttle accident. So we're interested in the probability of a safe flight, with none of the field joints failing. In our probability distribution table, we let our random variable x equal the number of failures, and we want to determine p of 0, no failures. Like when we were calculating the number. Okay, so I will share this video into the link here, and then you can watch it on your own time. So the idea was about the likelihood of the O-rings failure. So let's go back to our chapter slides. So let me first write down what it is that we saw here. So draw X. So this is X. Okay, give me a moment here. Okay. So a variable whose value is based on the outcome of a random event is called a random variable. So in this case, what the video that you just saw, the random variable is X. X stands for the number of failures. So the number of failures of the O-rings that they were looking at. And P of X, the probability of X, is the probability of it occurring. So the probability of, and I'm going to type in the probability of 0 O-rings failing, the probability of 1 ring failing, 2, 3, and I can keep going. So I'm going to make up some values now. What if the probability of 3 rings failing is 0.112 or 113? The probability of it's not letting me write. 2 rings failing is 0.322, and so on. Okay, so just to clarify, this is for this and this is for this. Okay, so now I'm saying that the values of X are all numerical. It starts from 0, 1, 2, 3, and so on. So they actually looked at 6 O-rings. So the values 0, 1, 2, 3, we know they're numerical, or we know they're quantitative, but we also know that quantitative data can be of 2 types. It can be discrete or continuous. So now can someone tell me what's the difference between discrete and continuous data? Do you remember what the meaning of discrete is and continuous is? Okay, so discrete data, which includes all these values of x, take on counting numbers. 0, 1, 2, 3. Oscar, you're right. Discrete is an integer. So it can be a counting number. Continuous data is, Priscilla, you're right. It's like a decimal or a fraction. So it's a non-integer, a value that is measured precisely. Okay, so for this chapter, in chapter 6, we're going to concentrate on random variables that have discrete data. So x in this case, a discrete random variable. A random variable is any value, any variable. In this case, we're calling it x. It could be a, it could be y, it could be anything. So we're calling it x as our random variable, and we're saying that it has only discrete values, so therefore it's a discrete random variable. And the probabilities associated with x can be calculated. So the probabilities associated with x will be in a column called p of x. So the likelihood that 0 O-rings will fail will be a certain value, and that can be calculated. The likelihood that 2 O-rings will fail is 0.322, and so on. So when I set up a table like this with values for x and values for p of x, the probabilities associated with x, then that means I have a probability model or a probability distribution. So what you're looking at here is a probability model or a probability distribution. So again, this is true for discrete random values. In the next chapter, chapter 7, we will look at values of x that are continuous. So that's our continuous random variable. So going on to the next slide. For both discrete and continuous random variables, the set of all the possible values and their associated probabilities is called the probability model. So that's just what I showed you. If I have all the values of x and the probabilities associated with x, then I have a probability model. Now, to answer your question, Jonathan, an example of continuous data is velocity for runners. An example of discrete data is number of siblings people have. Yes, exactly. So x is a counting number. If it's discrete data, so I'm counting the number of siblings, so that would be discrete data. And if I'm measuring the velocity for runners, that's a very precise measurement. That's continuous data. Correct. So just looking at the values for x in this chapter, the values of x start at 0, 1, 2, 3, and so on. And the probabilities associated with x would be a probability model. Now we can take this one step further. When the probability model is known, so when I have my x and p of x columns, then I can calculate the expected value. Now expected value is another word for, or another term for mean, the population mean, the average. What's the expected value? What do I expect x to be? What do I expect the number of failures to be when I have a probability model of the O-rings for the Challenger space shuttle? So the expected value is also, and I'm going to change the color here, is also equal to mu, which is the population mean. Okay, so that's where we have this mu, population mean. So what's the formula? Expected value of x is equal to the sum of a product. So sigma is sum of what product? X times p of x. Well, x is every single value of x times the probability associated with that x. So multiply the two and then add it up to get the sum. And that is your expected value of x, which is also your population mean mu. So we're referring to the population mean. We're not referring to the sample mean. So don't confuse it. Your textbook might use y instead of x, but it's the same idea. I'm just used to using x. So again, the expected value is the mean. And this although I said it's mean, it's not the usual way of calculating average. It's actually the weighted average. And you've seen this before in high school when you took an honors course or an AP course. The honors course is not equivalent to 1 credit. It might be equal to 1.05 credits, and the AP course might be 1.15 or 1.5 credits. So you take your grade value that you get for the course times 1.05 and then calculate the GPA. So that's an example of a weighted average. It's not just the average. So you've seen this before. So that's how you would calculate the expected value once you already know your probability model. So now we're going to do an example where we do this on our own. And let me go to the next slide. But actually, before I go to the next slide, I'm going to start with a little bit of a history lesson based on the example. So the next example is about an insurance company and the insurance company calculating probabilities. But let's backtrack. So I'm going to start with 1863. Can anyone tell me what was happening in the United States in 1863? So not 1963, 1863. What do you think was going on in the US?
Civil War.
Yes, thank you. The Civil War. So it was the height of the United States Civil War. And in New York City, there were a group of businessmen who decided to form a new company. And they wanted to form an insurance company. So what they wanted to do was to insure Civil War soldiers against disabilities and injuries that they suffered from the war. So it was quite a good business. But the thing is, after the Civil War ended, they had to change direction. So instead of selling insurance to Civil War soldiers against disabilities and injuries, they started to focus on selling life insurance. And they named this new company as Metropolitan Life Insurance Company. Now, why do you think they called it Metropolitan? I mean, you don't have to know, but take a guess. No idea? So this is New York City metro area. Yep, Colette. So because it was in the area of New York City, they call it Metropolitan Life Insurance Company. So after the Civil War, there was an economic depression, and it was about the 1870s. And now there were a few different life insurance companies, but the problem is because of the economic depression, the life insurance companies were going out of business. And in fact, a lot of companies were going out of business. But MetLife survived because what they did is they copied programs that were happening in England. They started selling this insurance policy called working men's insurance. So what they did is they insured small policies and collected premiums every week. And by the 1900s, MetLife was the nation's largest life insurer in the United States. And then it was the Great Depression in the 1930s. And again, MetLife expanded their business by diversifying their portfolios. They started favoring utility bonds, government security, commercial real estate, and somehow they survived the crash of 1929. They were, in fact, the principal investors in both the Empire State Building and Rockefeller Center. So they took a lot of risks, and even during World War II, the company was the single largest contributor to more than 50% assets in war bonds. So the idea of this entire story is to tell you that MetLife took chances, they took risks. It might have been very much different from what they expected it to be, but somehow they survived and they made good decisions that helped them in the long term. So for them, Karina, yes, high risk ended up being high return, but that's not always the case. So the idea is how much of risk And how did they figure out the probability? So probability has something to do with risk, right? So if you can calculate the probability of something, then you can figure out if that's a good enough chance to take or if you shouldn't take it. So that brings me really to the next slide. And before I read the slide, going back to MetLife, this was their logo for about 30 years. Does anyone know who that dog is? Yep, it's Snoopy, right, from Peanuts, and actually the artist died in 2000, Charles Schultz. So MetLife ended this 31 relationship with Peanuts in about 2016. I think they paid $12 million a year for licensing rights. And now they have a new logo. It looks like two simple shapes that come together. It creates something like an M. They say that the blue color ties back to their brand heritage, and the green represents growth. So, okay, now let's read the example. An insurance company, so we're not saying it's MetLife, but an insurance company, offers a death and disability policy. Okay, so that's their policy, death and disability, that pays $100,000 when a client dies, or it pays $50,000 if the client is permanently disabled. Okay, let's think about it again. They're offering a policy. You can purchase this policy. If you die, you get $100,000. And if you're disabled, and if you become disabled, you get $50,000. The company charges a premium of $500 per year for this benefit. Is this a profitable model? So this is the type of question that actuaries study, and this is what they analyze. Probabilities, right? What's the probability of something happening, and is this profitable to the company? So the company must know the probability before issuing such a policy. Okay, so I'm going to the next slide, and instead of explaining it on the slide, I'm going to use Excel because I think it's a cleaner way of doing things. So let me share Excel with you. Okay, so what you're looking at is the same example, but now it's a bit cleaner and it's set up in 4 columns. So before I start with the columns, there's some more information that is not in the slide that I have to give you. So the company says that out of 1,000 customers, so this information they already found, out of 1,000 clients, they found that 1 died, 2 became disabled, and the remaining 997 survived. Okay, so this is information that they already found. And now if they offer you this policy, there's a few different outcomes, right? Either you can die, or you can become disabled, or nothing can happen to you. And now the cost to the company is $100,000 that they would have to pay out if the client dies. You're told that they would have to pay out $50,000. And then how much would they pay if the client survives? And you can use your audio because I won't be able to switch back and forth. How much would they pay? Okay, they'll pay $0 if nothing happens. So this is my random variable x, and right now my random variable has discrete values, 100,000, 50, and 0. The next thing is I'm going to calculate the probability of x. Okay, so I know the answers are in the slide, but let's do this together. So I'm going to get Excel to do the work for me, and I'm doing this because you can use Excel for your homework and for your test. I don't expect you to do it manually. If we were in the classroom, we would pull out our calculators and do this manually. But you can use Excel, right? So first thing is for me to calculate P of X, I'm going to put an equal sign so that Excel knows a formula is going to show up. So I was told that one person would die out of 1,000 clients. So that's my P of X. Okay, so going back to this, you can see the formula in the formula bar here, 1 divided by 1,000. Again, equal sign, I was told that 2 people died, oh sorry, 2 people became disabled out of the 1,000 clients. So that value is 0.002. And then finally, I was told that 997 out of 1,000, nothing happened to them. Okay, so here's my 2 columns, X and P of X. I've calculated my probability of X. I'm going to calculate the last row as total. Okay, so I'm going to make this a different shade here. If I take the sum of my probabilities, so I'm going to go to sum, and it asks me if that's the range. That is the range, so all I have to do is hit enter. What should my sum of P of X be? Yes, so it should be equal to 1.00. And I can see here that I have an accurate probability model or an accurate probability distribution because every value of P of X is between 0 and 1, and the sum of all probabilities is equal to 1. Okay, so I set up my table. Now in the question, I am also asked, find the expected annual payout on a policy. Okay, so let's just go back here. Going to my slides here. The question says, find the expected annual payout on a policy. So that means I have to use my formula that we just saw, which is E of X is equal to the sum of X times P of X. So let's see, Gilbert, if that's correct. I need to share my Excel screen with you. So the next column is X times P of X. So again, my equal sign, and I'm going to tell Excel, take whatever is in cell B2, which is X, times whatever is in cell C2, which is my P of X, and I hit enter, and I've got my answer. So if I want to check, that's my formula up here. Then I'm going to copy that and drag it, and I get, if I check this again, it's B3 times C3. Last step is to do the sum, right? So if I do the sum of this range, that's my answer. So expected value is equal to E of X, and we said that's equal to the sum of X times P of X. So that sum is equal to 200. So how would I explain this? If the question is saying, find the expected annual payout on a policy, what does 200 mean? And you can turn on your audio to answer that. Insurance company, expected value, 200. What does that mean? So I'm going to stop sharing and go to the slide because it gives you the answer on the slide.
Maybe what they have to pay or their cost or something.
Okay, so let me share this first and then explain. Okay, so Stellan, you said out of the 1,000 people, 200. No, so that's not correct. Also, you said 200. No, so you're both not correct. But what do you? Priscilla, you were right. Um, we expect that the insurance company will pay out $200 per policy per year. So when you calculated expected value, that's sum of X times P of X, that 200 is what the insurance company will expect to pay per person on a policy. Gilbert, question?
I'm sorry, I left it by accident.
Oh, okay. Anyone else have a question for me? So remember, what you calculated is in dollar form, right? That's because X was the payout cost. So $200 is what they expect to pay. That's the expectation if they offer this death and disability policy. Okay, so I'm going to move on. Right, Stellan, you're right. They pay a $500 premium. Yeah. So this is what so yes, I agree. That's a bit high, but that's what the policy is. So, but they need to figure out what the cost is for them. So this is how they figure out the cost is for themselves, the insurance company. Okay, next is standard deviation. So you calculated expected value. Now we're going to switch to standard deviation. So this is the formula for standard deviation. But before we look at standard deviation, we need to look at variance. So variance is sigma squared, which is equal to, now think about this formula here. This is population variance, sigma squared. And it's telling you the formula is the sum, so sigma is the sum of some product. So what's the product? Well, we know P of X, that's the probability of X, which we calculated already, times this squared deviation. So what do I mean by squared deviation? Well, take every value of X and subtract it from the mean, that value mu, that expected value that you found. So take every value of X, subtract it from the mean, and then square it. And then multiply it with the probability. And then finally take the sum. That's your variance. But we're not only interested in variance, we're interested in standard deviation. So sigma, standard deviation, is the square root of your variance. So that's how you would calculate standard deviation. So we're going to do this now with the insurance company example. So I'm going to skip all the comments about the insurance company. Okay, I'm not going to get into that. We're going to talk about probability here. So going back to my Excel spreadsheet, because again, I would like you to do, so going back to this slide is showing you how to do it manually. So it's not that difficult to plug it into an equation like this and calculate it, but I prefer that you use Excel, because what if you have numerous values of X and numerous values for probabilities of X, and you're constrained with time when you're taking exam, get used to plugging it into Excel, and then you should be ready. Okay, so sharing my Excel screen. Okay, so we're here. The next thing we're going to do is, so we have this $200 for expected value. We need that number now to plug into the formula. So this is standard deviation. Oh, let me remove this. I don't need that. Okay, so same thing, nothing's changed. We have the policyholder outcome, payout cost, and probability. So I'm going to go back and copy these values and paste them here, just the values. We don't need the formula. This last row was total, so I'm going to highlight this. Okay, and we know that the expected value was 200. So 200, 200. Okay, now the formula is for standard deviation, and the standard deviation is the sum of or actually it's the square root of the sum of x minus, I can copy it right here. And this 2 is a superscript. Okay, so that's my formula, square root of the sum of this product. So let's break it down into 3 steps. First, let's do x minus mu. So my equal sign, and I'm going to tell Excel, take whatever is in x, subtract it from my mean that I calculated, which is 200. And then I'm going to copy and drag this all the way down. Okay, next step, x minus mu squared. So again, equal sign. So that means take whatever is in x minus mu times x minus mu and hit enter on the keyboard. So this is telling me x minus mu squared is 9.96 e plus 0.9. E plus 0.9 means 10 to the 9, which means I take the decimal point and move it 9 times to the right. Okay, plus 0.9. Take the decimal point, move it 9 times to the right. Okay, copy and drag this all the way down. Any questions for me so far? So if you don't know how these numbers came, I can go to the cell and you can see in the formula that I'm just following this formula on the top here. Okay, so the last step in this set of columns is to take x minus mu squared times p of x. So we have x minus mu squared here times the probability of x is here, and I hit enter. And I do the same thing all the way down. So copy and drag. And then final step is to get the sum. The sum, and it's asking me if that's the range. That range is correct, so I just hit enter. So now this is 14,960,000. So do I have my answer to variance or standard deviation? This sum is actually the variance. It's not the final step for standard deviation, right? So I need to get the square root. And can someone tell me what the square root of 14,960,000 is? And you can use your audio because I can't switch back and forth.
It's 3,156.
3,156.
Did I input that wrong?
I think it's not right.
67.8.
Say it again. 3,000.
867.
Okay.
1 on 82.
0.82. Okay, got it. And this is in dollar form, so I'm going to fix that. So that's the square root of 14,960,000. Okay, so everyone saw how we did this. So what does this mean now? It said that the expected annual payout we found was $200. So the insurance company will pay out or will expect to pay $200 per policy per year. That's what they expect to pay when someone purchases this policy from them. We also found that the standard deviation, how much it deviates from the center, how much it deviates from the expected value, is $3,867. What do you think about that number? So I'll stop sharing here. So that is this that we just calculated. You found that the standard deviation of the annual payout is 3,867.82. So it seems quite high for the insurance company to expect to pay $200 plus or minus about $3,800. So you may comment that the standard deviation is quite high. It deviates a lot from what they expect, but that's what the numbers tell us. That's what this particular probability model told us. So, it's up to them to make a decision now if it's too high of a standard deviation or too low. I want to make a point here that we're only using one random variable, x. When we use only one random variable in our probability model, it's called a univariate distribution because the probability distribution has only one variable. If you decide to take Economics 382 or Econometrics, you can get into something a little bit more complex where there are probabilities of combinations of two variables are looked at, and that's called bivariate distribution. But we won't do that. This course is not going to focus on bivariate. We'll only look at univariate distributions. Okay, so the next thing is I'm going to do a polling question and you're going to calculate probabilities on your own. But before you do that, let's walk through this example together. So, new example. It's about bookstore purchases. Suppose the probabilities of a customer purchasing 0, 1, or 2 books at a bookstore are 0.2, 0.4, and 0.4 respectively. Okay, let's understand this one more time. A bookstore has already figured out the probabilities. So they said the probability of a customer purchasing 0 books is 0.2. The probability of a customer purchasing 1 book is 0.4. And the probability of a customer purchasing 2 books is also 0.4. So before we read the questions, what you have to do is set up 2 columns, x and p of x. Now the values for x are 0, 1, 2. The probabilities of x are given to you. It's 0.2, 0.4, 0.4. You need to find the expected number of books a customer will purchase. So the bookstore wants to know what's the expected number of books a customer will purchase. So I'm going to help you set it up in Excel, and then I'll come back here and post the polling answer choices so that you can do it on your own from there. So sharing my Excel screen. Okay, so we're here. So before I start with that, I'm going to ask you, what is my discrete random variable? What does my discrete random variable denote? So think about it, right? You'll have to use your audio if you want to answer. Random variable is x. So my question is, what does it stand for? So in this case, x stands for number of books purchased. X is my discrete random variable, and x is number of books purchased. Okay. So the calculations part is not really hard. You need to really understand the question before you start plugging in numbers. So the question tells you that we know the probability of purchasing 0 books, 1 book, or 2 books. Probability of purchasing 0 books, you're told, is 0.2, 0.4, and 0.5, 0.4. Okay. Next step is, what is the expected number of books a customer will purchase? So I'll give you a few minutes and you can do this on your own. So I'll give you exactly 1 minute. So I should probably put the formula in here. Okay, so now I'm going to stop sharing and go back to the polling. And I'll put the answer choices here. So expected value is 0.6. Okay, so you should be able to see it. Okay, a few more seconds and then I'll stop the poll. Oh my goodness, I gave you some wrong answers. I'm sorry. I'm going to stop this. I'm so sorry. I mixed up all the, let's do it one more time. I am so sorry. Oh. Okay, here are the correct choices for expected value. Must have been going in circles. 0, 1. Okay, let's start this again. Okay, so you've already calculated the answer. Few more seconds. Okay, and I'm going to stop polling here. Okay, so most of you got the answer right. The answer is, and let's see. So if we go back to Excel and I calculate my x times p of x equal sign x times p of x, and then copy and drag this all the way down. And then I need my total here, which is the sum of that. And I hit enter. Then that is the answer, 1.2. So most of you are correct. The answer is 1.2. Any questions for me? No questions? Okay, we're going to move on to the next question. The next question says, what is the standard deviation of the book purchases? So actually, before we get into that, what does 1.2 mean? The bookstore says that they expect the number of books a customer will purchase to be 1.2 books. Now, I know nobody can purchase 1.2 books, but this is the average that you calculated. This is what they expect it to be, 1.2 books. Now the next question is saying, what is the standard deviation of the book purchases? So they expect it to be 1.2, but how much does it deviate from that expectation? So that's what the formula is up here, and you're going to continue with these 3 columns. Now we know this is 1.2, 1.2, 1.2. So you're going to take this and calculate the standard deviation, which is equal to square root the sum of this. Okay, again, I'll give you a few minutes and you can answer the question. Okay, so once you have your answer, I'm going to stop sharing and go back to the other screen.
Professor, the polling hasn't stopped.
Okay, thank you. So actually, I'll let that go on. I'll give you another minute on this screen and I'll go back and stop that and then give you the new poll. Okay, going to my Blackboard screen. I'll stop this. Okay, so you should see this poll now. Okay, a few minutes. Okay, and I'm stopping the poll now. Okay, so it's kind of hard to see who was really right because there's a few people who still didn't respond. So I'm going to go to Excel and try to figure out the answer. Okay, so here we are. We did expected value of 1.2. The next step is equal sign, tell Excel, take whatever is in X, subtract it from 1.2. That's the mean. And I hit enter. And then I copy and drag this all the way down. Next step is equal sign, take whatever is in X minus mu times the same thing because I want to square it, and I hit enter. And then I copy and drag this all the way down. And then last column is equal sign, so that Excel knows this is a formula. Take whatever is in X minus mu squared times my P of X, my probability of X. And I hit enter. And then I copy and drag this all the way down. And then the final step is to take the sum of that range, which is correct, and I hit enter. Now that answer is showing me as 0.56. Now remember, this is not standard deviation, that is variance. I need to get the square root of 0.56, and the square root of 0.56 is 0.748. So that would be the answer, 0.748. Be able to calculate standard deviation from variance and be able to calculate variance from standard deviation. So if I give you standard deviation of 0.748, be able to square that and get the variance. Okay, so you need to know how to do this. So what does this mean? This is saying that this bookstore expects the number of books a customer to purchase as 1.2 books, plus or minus a standard deviation of 0.748. That's what that means. So maybe in this case, standard deviation is not so high. Now, next question is this question in red that I'm going to ask you. Is this a probability distribution? Now, in order for me to answer that question, if this is a probability distribution, I need to look at my discrete values of X and the probabilities associated with X. So there are two conditions for this to be a valid probability model or a valid probability distribution. Every probability must be between 0 and 1. So we can see here that all these probabilities are between 0 and 1. And the sum of all my probabilities must be equal to 1. So that's correct. The sum is equal to 1. And we can see here that it's a discrete random variable X because the values of X are discrete values, 0, 1, 2. So the answer is yes, this is a probability distribution. Next question is, what is the probability of one or more books? Okay, I'm going to rewrite this in a mathematical term. So I'm asking, what's the probability of X is greater than or equal to 1? It's the same thing, but I'm asking it in terms of a mathematical formula. What is the probability of one or more books? What is the probability that a customer purchases one or more books? What is the probability that X is greater than or equal to 1? What do you think the answer is? And I won't be able to read your chat right now, so you can use your microphone.
Is it 0.4?
Okay, so how'd you get it? What are you looking at to get 0.4?
Well, I'm looking at the probability of an event. In this case, P of A is 1.
Okay,
And
so
P of
that's
B would
this.
be more than 1, but if it's 1 or more, then
Uh-huh.
it needs to qualify as 1.
So, okay, so again, remember in math, or is adding, right? So that
Right.
means find the probability of 1 plus the probability of 2. So that
it's 0.8.
means, yep, probability when X is equal to 1 plus the probability when my P's are lowercase, but oh well, X is equal to 2. So 0.4 plus 0.4 is equal to 0.8. Okay. So this example is very typical of the examples you're going to see in the homework for chapter 6. you have to get very comfortable setting up your probability model, calculating expected value, calculating standard deviation or variance if you're asked, and then what's the probability when x is greater than or equal to 1? Or in other words, what's the probability of one or more books? So you need to recognize that you would add when x is equal to 1, plus when it's greater than 1, and in this case we only have up to 2. Okay, let's do the next one. What is the probability of at most 2 books? Okay, so, okay, it's working. Let me change the color here. What is the probability of at most 2 books? So probability when x is, so the word at most means, I'm going to put my correct mathematical symbol here. When x is less than or equal to 2. The question is asking you, what's the probability of at most 2 books? Maximum is 2 books. They would purchase 2 and or anything less than 2 books. So that means you would include the probability when x is equal to 2 plus what?
X equals to 1 and 0.
Okay, yep. 0. Yep. So that means that's 0.4 plus 0.4 plus 0.2, which is equal to
1.
1.2.
Yep, 1. So again, get comfortable with the terms at most. At most means less than or equal to. At least means greater than or equal to. Okay, so at most is less than or equal to. Let's do one more. What is the probability of a customer purchasing less than 1 book? What's the probability of less than 1 book?
Zero point 0.2
How'd you get that?
is the probability of getting, purchasing less than 1 book is 0.2. But that means
Okay,
less than 1. That basically means
okay.
0, 0 books.
When x is 0. Yep. So that's how you got 0.2. Correct. Any questions for me? Okay, so this is exactly how I would expect you to do the homework and the next exam. I mean, if you get this and you're methodical with your calculations, be very careful, understand the question. It should be fairly simple. Okay, there's one last thing that I want to mention in this chapter. So moving on, we just finished this. So this is the last thing. And I'm mentioning this because you might have a homework problem that has this. What if you add a constant or you multiply x by a constant? So there are certain properties that you should be aware of. Again, you don't need to memorize this because it's open book, right? So if you add a constant, let's call it c, to your variable x, what happens to your expected value, what happens to your variance, and your standard deviation? Okay, so if you add a constant c to x, then basically you're adding the constant to your expected value, and then nothing changes with your variance or your standard deviation. Okay, so if you're adding a constant, nothing happens to your variance or standard deviation, but you have to add the constant to your expected value. Well, what happens if you multiply x by a constant? Well, here let's call this constant a. Then you have to multiply it with your expected value. You have to take the constant squared times your variance. And with your standard deviation, you take the absolute value of the constant times the standard deviation. So that's what you would have to do. So you don't have to redo the whole thing. If we quickly look at our insurance example, now we already know that the expected annual payout per insurance policy, we calculated to be $200. And we know that the variance was $14,960,000. What if the insurance company says, you know what, we're going to double the payout amounts. We're going to give them more in case they die or become disabled. So now the payout amounts are doubled. So what's the new expected value and variance? Okay, so this is something, a constant that you're multiplying. So what happens to our expected value? You take the 2 times the 200, and that's your new expected value. So they should expect to pay out about $400 per person per policy. And with variance, you take the constant squared, and this is your new variance. If you wanted standard deviation, you take the square root of that value, and that would be the standard deviation. So now your new variance is 59,840,000. Any questions for me? So I'm going to stop recording here because this is the end of our session for today.